We're going to go ahead and look at problem number 5, where we're asked to find the standard equation for a parabola. We're given some points. Examination of my points given. I think it would be fine to use the point 0, -4. If I use 0, -4, that will give me my c value right away because my x is 0, and the first two terms will add up to 0. So that'll be a good one, and that alone will let me put in my equations. So output is -4 is equal to 0 plus 0 because the x's are 0, and this is plus c, so therefore that leads us to say that c has to be -4. Okay, we got that one out of the way. So I think what we'll do now is we'll set up two more equations, and I think I will use the point 6, -10, and maybe the point 1, 0. Those are easy numbers to work with, 1, 0. And let's see what that gives us. Since 1, 0 is a nice easy point to work with, I think I'll build that equation first. Since output is 0, using the y is equal to 0, then we have a times 1 squared plus b times 1, and then we know c is already at -4. So this is an equation. So let's just simplify that up a little bit and write it a plus b minus 4. That'd be good enough. So using another point, 6, -10, I know that -10 will be, since x is 6, x squared is 36, so I'll put 36a, and then plus, then it's bx, so that would be 6 for x would be 6b minus 4. So we have an equation there. So I think what I'm going to do to eliminate now, since I have two equations, two unknowns, I'm going to take this equation here, and I'm going to now multiply that equation by -6. Okay, so I'm going to multiply times -6. So I'm going to rewrite that one. So -6 times 0 is 0. -6 times a is -6a. And then minus 6b, because -6 plus a positive b. And then -6 times -4 is a positive 24. So now that I've got it set up to eliminate the b, I can combine these two equations, and I get -10 is equal to 30a plus 20. Okay, so I've got that. Let's solve for a. So I bring the 20 on this side, and then this is -30 here is equal to 30a. And by inspection, I could tell that a has to be -1. So I'm going to write a is equal to -1. So I'm going to then use this simple equation here, and I'm going to substitute into this equation right there. I'm going to substitute a is -1 and then solve for b. So let's go ahead and set that up. 0 is equal to -1 plus b minus 4. Combine that, that's a -5. Put it on this side, and I get b is 5. Okay, so now I have it. My final equation is going to be y is equal to my value of a, -1 times x squared plus 5x, because b is 5, and then minus 4. I contend this now is my equation. Now, when looking at it, I see that my parabola does open down, and that suggests that I've got things correct. Okay, so let's go ahead now and put it in the calculator and see if it matches up. We'll first do it with those points that we used, and then we'll expand it to see how the other ones work. Okay, so let's go to second memory and hit 4 to clear our list, so we're ready to input our data. I'm going to go to Stat, Edit. I'm going to my X variable, and I notice I used the point 0, -4. Then I use 6, -10, and 1, 0. So the corresponding y coordinates would be -4 for that one, and then -10 for the 6, and 0 for the 1. Okay, we've got 3 points on a parabola, and that's enough to define it. So let's go ahead to Stat, Edit, not Edit, Calc. cursor over to calc. Then we're going to use quadratic regression. So that one's number 5. And x list is L1, y list is L2. And let's store our regression equation in y1. So we're going to go vars, y vars 1, 1, and hit enter and then calculate. And we notice that with 3 points on a parabola, we are going to get a perfect parabola. And notice our r squared is 1. And there are coefficients that match up to what we expected for a, b, and c. That'll match. Now let's just see if the other points are on that parabola as well. We could do a substitution and check it that way and a couple ways. Let's go to the home screen and let's double check. We have our regression equation in y1. Notice it's got tons of values there and those are all accurate. So let's quit out of that and let's just go to the home screen and hit vars, y vars 1, 1. And let's put in the value for 2. And if 2 is on this parabola, we should get an output of 2. And hence we do. So we've checked that point. And let's also go and check the point 4, 0. So I will hit vars, y vars 1, 1. And then I will put in the point, the x value of 4 to see what the corresponding y is. And our calculator gives us 7.2 times 10 to the minus 2, which is pretty much 0. And so our question is, maybe 40 is not on that. Well, was the calculator going to lie? Well, maybe not. But let's put 4 in and let's do it manually. Let's see what happens. Okay, so we're doing y when x is 4, which is going to be negative 1 times 16. So that's negative 16. And plus 20. Minus 4. And in fact, we get a value of 0 there. So analytically, we see that we don't have any problems getting that, but we could always question ourselves, why did our calculator not get what I consider exactly 0, when I would think that equation would do it? One inspection might be is if you look at your equation and see is it rounded by any means. And notice there is a 1, 1 on the end there. So there's something to do with the regression feature of our calculator that does induce a minor amount of error into what we get. So therefore, that's why we got that little bit of difference when we really should have gotten the 0.40 exactly on a parabola. We didn't. Hopefully that helped out.